Hey, 8th graders. So here we are starting chapter 1. We're going to be talking about rational and irrational numbers specifically. And so today's focus is on rational numbers. There we go. Now it's going to click. So a rational number is a number that can be written as a fraction, or it could also be written as a terminating decimal or a repeating decimal. And so a terminating decimal is when our decimal ends in zeros. And so we stop. So like 1/4 becomes 0.25. And so that's a terminating decimal. A repeating decimal is a decimal expansion that repeats the same digit or block of digits without end. So like 1/3 is 0.3 repeating, but really any decimal that repeats, like even if it's 1, 2, 1, 2, 1, 2, and it just keeps repeating forever, that would be a repeating decimal. So that's what we're working with today. Now, when we talk about a decimal expansion, basically we're starting from a fraction and then doing the division, long division to find the decimal expansion. Now, yes, we are still working without calculators right now because that is part of our state standard, is understanding how numbers work. And so that's what we're working with today. So example 1, what is 3/16 written as a decimal? And yes, it would be awesome if we just type 3 divided by 16 into the calculator, but unfortunately that's not what we'll be able to do when it comes to our state test. So numerator goes inside, denominator goes outside. 16 does not go into 3, so I'm going to put a 0, and then I'm going to put my decimal in both the top and bottom, or inside and on top. I'm going to add a 0. And then I ask myself, how many times does 16 divide into 30? Or what times 16 gets me close to 30? And the closest one is just once, and that is 16. And so then I'm going to do 30 minus 16, and I end up with 14. 16 does not go into 14, so that's a good sign. That means that I did find the biggest number that goes in. And so now I'm going to add a 0 and drop that 0 down to make this a 140. Now, I need to figure out how many times does 16 go into 140. And so here are things that I do when I'm trying to do this in my head. I know that 16 times 10 is 160. So we're pretty close to that. I'm also going to do 16 times 5 because that's going to help me as we continue on. And the reason I do times 5 is because that's halfway, right? And so 6 times 5, or 5 times 6 is 30. Carry the 3, 5 times 1 is 5, plus 3 is 8. So I know that 16 times 5 is 80, 10 is 160, and so I know I want to be a number closer to 10, between 5 and 10, but closer to 10. And so like maybe I try times 9, because 16 is a pretty big number. So let's see. 9 times 6 is 54. And then 9 times 1 is 9, plus 5 is 14. So that puts me at 144, which is greater than 140, just barely. So what that means is I want 16 times 8. So I'm going to go ahead and put the 8 over here. And now I'm going to do 16 times 8. 8 times 6 is 48. And then 8 times 1 is 8, plus 4 is 12. So we end up with 128. And then I'm going to subtract. I've got to borrow. So 10 minus 8 is 2. 3 minus 2 is 1. All right, 16 doesn't go into 12. I've got to bring down the 0. So now, how many times does 16 go into 20? Well, or 120. Well, 8 times 16 was 128. So 7 is our next best bet. So I'm going to do 16 times 7. 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11. And so we get 112. And now we do some subtracting. So 10 minus 2 is 8, and that's all that's left. And so now I bring it down another 0, and 16 goes into 80. Oh, look, I've already done that one 5 times. And so written as a decimal, 3/16 is equal to 0.1875. And we're using long division, which we've been practicing in our warm-ups, to find our decimal expansion. All right, so here's our next one. We are trying to say whether they are equal or not equal. And so we're going to have to do some dividing to figure that out. Now, the bar over a number in a decimal means repeating. So like on A, I'm comparing 5/9 to 0.5 repeating. And so now I'm going to take 5 and divide by 9. 9 does not go into 5, so that's a 0. So we're off to a good start because we start with a 0. All right, and then 9 goes into 50 5 times, because 5 times 9 is 45. And then I do some subtraction, and I'm left with 5 again. And so then when I bring this down, 9 goes into 50 5 times, and that would be 45. And I'm left with 5 again, and that cycle is just going to keep repeating and repeating. So 5/9 is equal to 0.5 repeating. All right. B, 5/9, we already know is 0.5 repeating. So is that equal to 2.6? No. It's not equal to 2.6 repeating. Excuse me. So 5/9, we already did it over here. Obviously not equal. All right, so now we're at 7/6. So I'm going to do 7 divided by 6. 6 go into 7 once. Subtract, we get a 1. Now here's the thing. I'm comparing this to 0.16. So at this point in time, I can stop because I'm at 1 point, and I already know that we are not equal to 0.16 repeating. I may end up getting 1/6 repeating, but it's not 0.16 repeating. So that makes it a not equal. Right now over here, 1 divided by 11. And 11 doesn't go into 1. 11 does not go into 10, so 0.0. From here, I'm now asking how many times does 11 go into 100? Well, it goes in 9 times. I'm left with 99 and then 1. And you may want to say, yes, but we're not done, right? This was 0.09 and this is 0.09, but I'm not done dividing. I've got to bring another 0, and then it's another 0 and another 0, and it goes in, and I just keep ending up with the same. And so 1/11 is 0.09 repeating, which is not equal to 0.09 because one repeats and the other does not. We have one last problem where we're doing decimal expansion. We are going to compare 0.03 to 10/33 miles. And so I'm going to take the 10. It is easier to compare in decimal form. So 10 divided by 33. 33 does not go into 10, so that's a 0. And I add a 0. 33 goes into 100 3 times, which is 99, leaving us with 1. Add a 0. 0, and then add another 0. And then we go in 3 times, which is 99, and I'm left with 1 again. And I hope you see the pattern. It's just going to keep going. And so I know that 10/33 is 0.30 repeating. which you may say, okay, well, 0.3. At this point, to compare, I'm going to take 0.3 and I'm going to expand it. I'm going to compare it to our 0.3 repeating, or 30 repeating. All right, so the first two digits are the same. The third digit for 0.3 miles is another 0, whereas my 10/33 is a 3. And at that point, now I can say that 0.3 is less than 10/33 of a mile. And the reason is because 303 is greater than 300. And so 0.3 is less than 10/33. And I know long division is not our favorite, but it is what it is, and I've got to have you prepared for that state test, and you're not going to be allowed a calculator for some of these, so we just got to get used to doing it. I'll see you on the flip side.